Up here we called it the points data file, and down here we called it points file name. Let's be consistent. We have data file name and we'll have points file name. So down here we refer to the same points file name. And no warnings. So we can test that the points data are coming in properly. Do the update again, and now let's ask for the data, and we called it points data. And indeed we get a list, and that's a list that starts with 2 strings, and the rest are numbers, which are all the x and y coordinates for a 2D profile. So the next step in creating a profile is to fit a curve through those points. So the way that we can do that is with a fitted curve, but let's define a specialized object that simply does take those points and create a fitted curve. So we'll make an object here and we'll call that the canonical profile, because this will be a profile curve which exists in global space at the origin, and then we can use that same curve to transform it around to the different locations and orientations that we will need to make the lofted surfaces for the wings, etc. But we'll work with this one canonical profile, so only in one place does it have to read the points, do the fitted curve, and so on. So this will be of type profile curve, which is a type that we will define in a minute, and it will need the points data. So that points data comes from our data object, the data points data. So profile curve doesn't really have to mix anything in. Its input slots are the points data. It can mix in fitted curve. So if we take a quick look in the documentation, get an idea, in the surf package we have an object called fitted curve. So fits a curve through a set of points, and the only required input is called points, which is a list of 3D points to do the fitting. We can optionally specify a degree and some other indicators for the fitted curve. But for today, let's just give the required input of the list of points and let everything else go to the default. So if we use fitted curve as a mix-in rather than as a child object, perfectly legitimate to use the fitted curve as a mix-in. So now our profile curve essentially is a type of fitted curve, and we're passing in this points data, and now we can override the input slot for points by making a computed slot within our own profile curve. So computed slots, points, those are the actual points that will go to the fitted curve to do the fitting. And notice the first 2 items on our points data are names. They're not the points. The rest of the data is x, y coordinates for the points. Now this needs to be a list of 3D points. So I'm going to call it the 3D points list. So we need a computed slot here called 3D points list, which will contain the actual list of 3D points built from those x and y coordinates. So let's get the data in a stepwise manner. So first of all, the point coordinates is just a list of numbers, and that will be the rest of the points data. So rest will strip off the first element, another rest strips off the next element. So that gives us the points data starting at the 3rd element, which is what we want. Now if we think of the rest of these points as a p-list, where the keys are the x values and the values are the y values. Let's take a look at that file again so we can get an idea of what that means. A p-list is a list of pairs where you have a key and a value. So if we simply think of this first number as the key, the second as the value, the first is the key, the second is the value, and so on, then we can use some standard plist functions in order to get at all of the x values in a list and all the y values in a list. So the x coordinates we can think of as the plist keys from the point coordinates. And these are standard functions from Gendel that operate on plists. We have plist keys and we have plist values. So the y coordinates we can think of as plist values. Let's compile this for a minute and test it. Again, we have one warning, undefined function 3D points list, which is legitimate warning because I have not yet defined this 3D points list. So we'll leave that be for the moment and go to our command line and update. In our object, we've named this instance as the canonical profile. So let's ask for the canonical profile, and it is a profile curve, as you would expect. Now let's first of all ask for its points data, and there's the list of data. Now let's go right for the result that we have so far and ask for the canonical profile x coords and y coords. So those look like the correct values. Now we have to construct a list of 3D points, and we'll learn a new operator now called mapcar. Mapcar allows you to specify a function that gets applied to each element in one or more lists in order to produce a new list. So we'll produce our 3D points list as a mapcar. We're going to map some function across the x coords and the y coords.